As you can see, this will be the result after the end of this video. Welcome everybody. In this video, we will be making a number classifier project. It will be a beginner's level project. In this project, when we give our model a picture of a number, then it will correctly predict which number it is from 0 to 9. So before moving, this is our channel Machine Learning with Rohit Narwal. So kindly like, share and subscribe to support us to make such quality content for you. So let's begin by creating a new notebook in Colab. So let's create. So now let's change its name to number classifier. To make the things easier, I have already created the project and the file is stored at this location. So it's https://github, then there is rn, this is the repository, so you can find that, and I will just explain how everything works. That will speed up the process of learning and making. So let's begin by giving some introduction about the project. For example, its name, its use case and its location. So now let's begin by importing the modules. So there are a number of modules we need to import. So the first one, TensorFlow, will be used to make our models for compiling and everything else. And the second one, Keras, it's a library in TensorFlow that we will be using. Then the matplotlib we will be using to plot our graphs and data. And the NumPy module will come handy in normalization, vectorization and other matters. So now let's start by loading our data and making training and test data. So using this line, we are importing our data set from keras.datasets.minst. So it consists of our data. So it's a pre-processed data set with 70,000 examples. So now we have loaded our data. So it will be stored in this variable, and load data is the function to load the data from the database. So now let's import our training images, test images and their labels. And using this, we can import our data. And there are two ways to import data. The first way is our basic method. Using this, first of all, we make a variable of num, means then we load that data into our images and labels. But the second way is directly uploading the data into the images and label. As you can see both methods on your screen. It's loaded. Now next thing is we need to shuffle them. So this is the moment we will be using NumPy. So using np.random.permutation, we can shuffle our data. So what it does is, let's say if we have an array and it will just randomly permutate it, and it will make a copy of it and shuffles the elements randomly. In our case, we have 60,000 training data and 10,000 test data, so it will shuffle them and return a random array. So we have shuffled our data. So you can just take your data in this ratio 6:1. So now using the shuffle index, we need to make our training data and labels random. So using this line of code, our work is done. So you need to make sure one thing, that you input shuffle index train in both of them in the case of images and labels, to make sure that the exact image get the exact label. So now let's shuffle our test data and label. So it will be the same process, but it will consist of shuffle index test instead of train. So now let's reshape our images. So the reason to reshape our images is simply to reduce their size and make our model work faster. So now let's talk about the parameters. The first parameter is the number of images we are applying on, and the second and third are the dimension we want to use for the image, and the final one is the RGB number, which in our case is 1, since we are using grayscale images. So now let's add mean normalization to our images. If you do not know what is a mean normalization or normalization, then you can check out this video. I have taught everything about normalization, how to use it, how to apply it. So now let's apply reshaping and mean normalization on our test images. So now everything done, let's make our model. So we will be storing our model into a variable named model. So let's begin. So we will be making model using tf.keras.models.sequential. So the sequential in Keras helps you create model layer by layer. That means inside this we can create multiple layers like LSTM, convolution, polling, dense, flatten and many more. And the keyword model is used to make our system understand that it's a model, and the Keras and TF are the libraries. So now let's just copy it and paste it into our Colab. And now let's talk about convolution and pooling. So let's start by convolution. The reason we use convolution is to extract features from an image. For example, if we give an image of a dog, then it will find out features like nose, ears and many other features. And when we give it a next image of a dog, let's say, then it will easily detect it as a dog. So now let's talk about the parameters inside the convolution. So the first parameter, the 64 here, is the number of filters. So what is a filter? Well, it's something which we use to take out important features from our image. So let me just show you filter for convolution neural networks. Wait a minute. So it's something like this. So as you can see, it's a kernel filter, and this is our input image in forms of pixel. So what it does is it takes out a 3 by 3 matrix input pixel, then it will multiply every corresponding pixel of our input image with the filter pixel and store it as a new pixel. Then it will add up all the new pixels and get a new pixel. That pixel will be our new output pixel that we will be using for padding. So this will help us take out important features from an image. So now then what is 3,3? So 3,3 is the shape of a filter. So it means that it will have 3 rows and 3 columns, and the activation ReLU means it will take out the negative values from the output pixel, and it will put the 0 instead of negative values in the output pixel. The input shape here simply means dimensions, and 1 means the layers we are using for our RGB. So here we are using a grayscale image as our input, so it will be 1. But if we have used a colored image, then the RGB will be here 3. So now it's done. Let's start max pooling. So max pooling is nothing rocket science, it's just another filter. So the parameter you can see here, 2 by 2, is just the shape of the filter. So what it does is it runs the filter on our output shape and then select the maximum value from the 2 by 2 matrix. So let me show you with a clear image. So let's say this is the one. So here 12, 28 and 12 are there. So it will take the maximum value, that is 20. And in this case it's 30 then, and then it will, from this one it will take 112, and from this one it will take 37. So it takes important features from our picture. So this will help the model to focus on important features and help it remove the background or the horizontal and vertical line. So that's it. So we will make another layer of convolution and pooling, and let's print our model summary. Then you will be able to understand the importance of these layers before and after their use. But before that, flatten simply means that it will convert our 2D picture into a 1D array. So let's say it's 28 by 28, then it will be around 576 I think. And the last thing, the dense layer. As you know from our previous projects, a dense layer is nothing but a simple layer of neurons in which each neuron receive input from previous neurons. So here the 256 represents the units, that is the number of neurons it will be using. So using 256 neurons, it will try to find multiple features from the picture. And the second parameter, activation equals to ReLU, means it will take out negative values from our output array, if any present, and put a 0 instead of them. And now the softmax function. So softmax is simply a multi-class classification. So it will classify multiple things. So it's actually the last layer, and it is used for classifying multiple category of inputs. So that's it. So now let's print our model summary. Wait a minute, let me just run everything again, restart and run all. So now sequential SUMM. Okay, sorry for the error. So as you can see, the shape after the first cone 2D, it's 26,26. That's because when we run a 3,3 matrix across the our 28,28 matrix, then we will see that it will lag to run on the last two pieces from up and down. That's why it's 26,26 instead of 28,28. You can easily verify it. So the shape comes out to be 26 by 26. And when we apply max pooling, as you can see, it drops into half. So the number of rows and columns cut into half. So it will be 13. And in the next convolution layer, it will remove again 2 from right and 2 from down. And in the pooling layer, it will reduce it by half. And then final shape will be 5,5. And you can see after flattening it, the shape is about 1600, which is correct. As you can see, our final output shape is 5,5,64. So if you multiply them all, it comes out to be 1600 exact. So it has flattened our data correctly. And there are 256 neurons, then it has 20, and you can see everything here. So now our model is done. Let's move on. So now we have made our model successfully. Now let's just make a callback function, or you can say callback class. So what this does is, whenever our model reaches a specific accuracy or a specific target, let's say if I wrote here loss, then it will check for loss. So in this case, whenever it reaches 98% accuracy, it will stop training. So this will save a lot of time. So we have made a class to use this function. So we have given it a name, then we have given it a parameter tf.keras.callback, and then we have made a function which checks for epochs and logs. Now whenever logs dot get accuracy reaches above the 98.98, which is 98%, then it will stop training. So this will write self.model.stop training. So now let's make an object out of it. So this will be the object. So we will be calling it using this object. So now let's run it. It's working fine. Now let's compile our model. So it's same model.compile, and optimizer will be stochastic gradient descent. So I have talked about gradient descent in my previous videos. So you can see from, wait a minute, here gradient descent for multiple features in 5 minutes 12 seconds. So you can watch it, and I have made another video too. So here it is, gradient descent machine learning, and then I have talked about the use cases, so you can watch that. And we are using sparse categorical cross entropy for the loss. So categorical cross entropy means that we will be classifying multiple things, so multiple features will be used. So now let's fit our data. Wait a minute, let me just give them a heading. So I will be storing the output into the history variable to use it in the further process into the history variable. So I can modify something using this. So now let's just fit our data. So I have already defined the callbacks. So using this thing, callbacks equals to, then here the name of the object will come, which is callbacks. If I have changed this, then I have to change here too. And I have used 20 epochs, and then training images and training labels. So using them, it will train. So it will take some time. So see you after completion of this. So now as you can see, it says reach 98% accuracy, so cancel training. So it has cancelled training after reaching 98%. So now our training is done. We need to evaluate our data. So let's see. So it has a pretty good accuracy. So it's about 97% accuracy. So that's good. Now let's just plot our data and predict. First of all, let's print. Wait a minute. Now let's predict and plot the predicted data. Predicting on data. Predicting. So let's see what it shows, and maybe this could work. Yeah, it's working fine. So as you can see, it's 8 here, and it's predicting 8. So let's try something other. So let's take the test image number 200, and what's the label it will print on it. So it's predicting correct. So as you can see, it's predicting well. So let's try again. So it's working fine. So our model is complete. Now before you leave, kindly subscribe to our channel, because we are so close to reaching our goal of 200 subscribers. So thanks for all of your support, and stay hungry and stay foolish. It's truly said by Mr. Steve Jobs. So see you later.